Welcome back to Using Python at the CHPC. This is the last video for this lecture series, and this is a summary of strategies for using Python effectively at the CHPC. So we've talked about a few different mechanisms for connecting to login nodes. We talked about SSH. You can get optional graphics support through SSH with X forwarding, which is not something I mentioned, but it is covered on the CHPC's documentation on SSH if that's something you need. You can also connect using FastX or with the shell access tool of Open On Demand. Now there are different use cases where different options would work well. The matrix here is just my personal opinion on the matter. So if you're using, for example, Python in an interactive fashion where you're just running commands from the interpreter, so if you're just running Python 3 and then typing in Python commands, really any of these could work well, although with the caveat that Open On Demand lacks support for graphics in the shell access tool. So you wouldn't be able to, for example, interact with a plot in matplotlib. Any of these would also work well if you're just running a script like Python 3 and your script name. If you're wanting to use a Jupyter notebook, I would recommend just using Open On Demand for that because it tends to work much better when you're running it locally in your web browser, as Open On Demand allows you to do, versus trying to connect through a remote desktop session or otherwise, although it is possible to do this. In terms of remote editing with VS Code and others, this is not something I've really talked about in this presentation, though we do have documentation on how to use VS Code with CHPC systems. We find that VS Code actually uses significant resources, and so we wouldn't recommend running remote editing workflows on login nodes. You can do this on a compute node, though you will need a little bit of a workaround, which we'll talk about in a minute. And then I also haven't mentioned workflows with tools like SnakeMake. So SnakeMake is a tool that allows you to run a defined workflow that will get you from some starting condition to some ending condition. So for example, you can define a rule that says, if I don't have a file named plot.png, then run this script that generates plot.png. So it's a way that people like to organize their code in cases where they're running the same sort of workflow on a lot of different inputs. And realistically, you can do any of the connection methods to use workflow tools, although again with the caveat that Open On Demand shell access lacks support for graphics. Now if you want to run Python on a compute node, again this is useful if you want to run something that is large or long running. Then you have, again, the three options that we talked about in the previous video. This is actually backward from the order we talked about them, so I'll start from the bottom here. You have Open On Demand through the interactive apps that we mentioned. So for example, the Jupyter Notebook option. You can use the salloc command from a login node to submit a Slurm job, and that will allow you to interact directly with that compute node once the resources are allocated. Or you can use the sbatch command, again from a login node, to submit a script that Slurm will run once there are resources available for it. And then the columns here are the same as the previous notebook. So in this case, if you're running a Python script, so if you have a file like some script name.py, I would say that using sbatch and submitting the job so you don't actually have to interact with it is the ideal option. And similarly, it's the ideal option for workflows if you're not interacting with those. If you're running Python commands from the command line, then using the salloc program is a good option, with the caveat that you may need to wait in a queue for resources. But if you're running a small job, then a queue like Notchpeak Shared Short is a good option. And if you're running a Jupyter notebook, then it is ideal to use the Jupyter application on Open On Demand, because that'll run the notebook itself on the compute node. So you get all of the resources that are available through your job allocation on Slurm, but the notebook itself is running in your local web browser, so it's very responsive and fast. Now, if you want to use VS Code for remote editing, I mentioned in the previous lecture that this can use significant resources, especially if you're running the scripts that you're editing or testing them. So we wouldn't recommend doing that on a login node, but it is possible on a compute node. You would need to start a job for this. So start a job on a compute node that you could use as the resources for your remote editing software. And then you would connect to that from, for example, VS Code on your local computer. And we have some documentation on how to do this because it will require using what's called an SSH tunnel, simply because the compute nodes on CHPC systems are not accessible directly from the internet. So depending on what mechanism you're using to run Python, whether you're running it interactively, running a script, using a Jupyter notebook, etc., and whether you're on a compute node or a login node, then the ideal way for connecting to CHPC systems is going to vary. So I would recommend just taking a look at this matrix. Again, it is subjective, so you certainly can find ways to work around some of these not recommended or possible cases, and just give it a try. And try running Python, see what works for you, see what you like to use best. So if you have any questions at all about this presentation or its contents, please don't hesitate to reach out to us. You can email us at helpdesk@chpc.utah.edu. Thank you.